Welcome friends for our new session on control engineering. In the previous sessions we have studied about the block diagram algebra, general representation of a feedback control system and the rules of a block diagram algebra. So in this session we are going to study or we are going to solve numericals on reduction of block diagram to obtain a closed loop transfer function. Let's go with one simple numerical. Let's go with the numerical first. Here we are having the question as stated here. To determine the transfer function C of S by R of S of the system shown in the figure will be given as below. So when we observe this figure, what we are supposed to identify, how many forward blocks are there, how many summing point are there, and the takeoff point before going into the solution of the problem. So here you can see one summing point. Next to that one we are having another summing point. There were two forward blocks here, G1 and G4, and forward block G2 and G3 which are parallel, and one summing point at the later stage, and a takeoff point taking away the signal passing through the feedback block H2, and one more takeoff point passing a signal through block H1 feedback block and bringing it to the summing point 2 here. So this is the given problem. When we see the problem, the more important thing is to identify how many forward blocks are there, and is there a possibility of combining the forward blocks and bringing into either in series or parallel. So it is important for us to first, when we see the given problem, to identify any blocks which can be converted into a single block by bringing or reducing them into a single block by applying the rules like series or the parallel rules. So here we can see there are block G2 and G3, and this is going to be the forward path and it is coming to the summing point. This also is a forward path which is going into the summing point. So when we combined this whole block here, this will be coming as parallel. And next we can see there are two blocks G1 and G4. This can be cascaded and brought into series. Let's see. Let's go with the problem. So step 1, the block G2 and G3 are in parallel. So combining them we get G2 plus G3. So when we combine this whole block G2 and G3 with the summing point, what we get? We get the block as G2 plus G3. So this will be a single block. So this block we are going to replace in this particular path. When we replace into this path, we get the block converted into G2 plus G3. So this is coming into the forward block. Next, what we see is, we see another block here, these two blocks which are in a series. So here, after combining these two blocks G1 and G4, as they are in series, the block will be written as G1 into G4, which will write it in the next step, in the step 2. So the replacement of these two blocks in series will be by G1 and G4. So the block G1 and G4 are in series, so combining them we get G1 into G4, and which is written into this particular block. Now we can see there is one forward block, one summing point. Here also there is one summing point, and by default they are having plus A, and we can see there is one takeoff point and feedback block, and there is a summing point. So this whole thing will be created into one minor loop or a minor feedback loop. This is going to be created as a loop. So what will be the replacement in this loop? There is a forward block, so we will be having the replacement for this one as in the forward block G1, G4 all divided by 1 minus G1, G4 multiplied by the feedback block H1. So this is the canonical form of writing for a closed loop minor feedback loop. So this will be the replacement in this minor feedback loop. So which we are going to see it in the next step, that is step number 3. So in step number 3 we can see the minor feedback loop 1 in series with the block G2 and G3. So here we can see the loop 1. This is the loop 1 which has been getting reduced. Loop 1 has got reduced, and we got one single block. So this single block is having the forward block of that loop G1 G4 and 1 minus G1 G4 into H1, that is the feedback of. Now what we can see here, this loop 1 and this block, both of these two blocks are in series. Both are in series, hence they have to be multiplied. In between they have to be multiplied. So when we multiply this block with the next block which is in a follow up with this one, what we can get, we are going to get the block as G1, G4 bracket G2 plus G3 all divided by 1 minus G1, G4 and H1. So this is what is the block which is going to get replaced into this particular series elements. So this is what is going to be replaced in our next step, that is fourth step, the minor feedback loop 1 in series with block G2 plus G3. So here we can see the feedback loop getting converted, that is second feedback loop happening, and the previous block has been replaced here. So we get G1 G4 G2 plus G3 and 1 minus G1 G4 and H1. Now when we see this particular system, we are having one summing point, one forward block, one takeoff point and one feedback block, and the signal is going in forward here and takeoff is happening and the signal is coming backward, and this signal is getting summation at this summing point, hence this forms a canonical loop. So this one will be the next loop in our system. So this is completely the next loop in the system, and we'll name this as a loop 2. loop 2. So when we see the loop 2, we are having one forward block. We have to make the formation of a canonical form. So for that we have to identify there is one forward block, one takeoff point, one feedback block, and one summing point. Hence, how to go forward? For that, what we should write is, we should write it in this particular form. Here we are going to get the transfer function for this particular block or for this loop. So in the numerator, what we have the G block. In place of the G block, what we get? G1, G4 bracket G2 plus G3 whole divided by 1 minus G1, G4 and H1. So this whole element is from the forward block. Then as we are having a negative sign, so it will be written as 1 plus, next we are having again the G term. The G term is this one, G1, G4 bracket G2 plus G3 whole divided by 1 minus G1, G4 into H1. Next we are going to multiply with the H block, that is H block is here H2, so it is getting multiplied by H2. This is what we are going to get. After getting this one, we need to simplify. So when we are going to simplify, so what we are having? We are having a denominator term here and we are having a denominator term here. This has to be taken LCM. So LCM of this one. So actually how we can go is, we can write it as G1. I am rewriting it. Whole divided by, when we take LCM of this one, this is going to get multiplied by 1. So hence we get 1 minus G1 and H1. This work you can do it at a rough work also next to it. Then denominator of this term and denominator of this term are going to get cancels. What remains is the numerator term here, G1, G4 bracket G2 plus G3 and the another whole divided by denominator 1 minus G1, G4, H1 plus G1, G4 bracket G2 plus G3 into H2. So this is our output. Next step is to write it into a single block. The overall transfer function, we call it as a overall transfer function for the given block, that is written as C of S divided by R of S equal to, in the numerator G1, G4 bracket G2 plus G3 whole divided by 1 minus G1, G4 H1 plus G1, G4 bracket G2 plus G3 into H2. Let's go with the next problem. Determine the transfer function C of S by R of S of the system shown in the figure. So in the given figure, we are having the first summing point, the second summing point, a forward block. After the forward block, there is a takeoff point. The forward block is G1 and G2, and in between G1 and G2, there is a takeoff point. And between G2 and the third summing point, we are having another takeoff point. And parallelly, we are having for G2 a forward block G3. So this is parallel. Next, we are having a G4, a forward block from the summing point 3, and there is a takeoff point, common takeoff point passing through block H1, and one more takeoff point passing through a unit feedback. We call this one as a unit feedback. There is no block, then also we represent as a unit feedback. Through this it is going to pass. And there is second takeoff point here. This is third takeoff point. This is second takeoff point. Second takeoff point is passing through block H2 to the second summing point. and there is a first takeoff point which is passing through the block forward block G3 to the third summing point. So usually if this is coming in between, we can't use our series rule. We have to make the modification. So that modification we have to make. Then here we can see there is summing point here. This summing point can be splitted. So this summing point can be splitted. Let's see how we can do this one. This is the given problem. Let's see the problem. Here in the step 1, we are splitting the third summing point and forming a block G4 and H4 into a minor feedback loop. So as I have told you, we are going to identify the third summing point. So this summing point we are going to split. So this is going to be splitted, and this summing point is going to be having output forward block G4, and it is having a split of a takeoff point also. We can have this one like this also, no issues, or we can identify this one itself here itself only. Then this is having a takeoff point here, and it is passing through the block H1 and coming back into the system like this. So this is going to be the loop. Let's go with the problem. Here step 1, we are splitting the summing point and forming a block G4H1, which is going to be a minor feedback loop. Let's see the problem. So in the problem we are having here at the third summing point, this is we are going to split and identify that there is one summing point, one forward block and one takeoff point and one feedback block, and the whole of this system is going to be creating one minor feedback loop. So this block, this is going to create a minor feedback loop, or we call it as a loop 1, which is having a forward block. Half of the summing point will be retaining, but only splitted half of the summing point is going to be included. So it will be a canonical form which is written in the form of G4 whole divided by 1 plus y plus, because it is having a negative feedback, the forward block G4 and feedback block H1. This block is going to be replacing this part, and the summing point of this one will be retaining there itself only, and it will be coming in the next step. So this is what we are going to do in this particular block, which we am going to show you in the next step 2. The next step, in step 2, the block G4 and H1, how they are formed into a minor feedback loop, that I am going to showcase here. So here we can see the minor feedback loop has been formed here with the retaining of the first, second, third summing point again, that is the split part of the summing point is been retained. Now next what we require to do here is we have to identify the takeoff point which need to be shifted. So identification of the takeoff point, either we can shift this one here or we can shift this one on the other side. So here we are trying to bring these two, G1 and G2, in series. So to make these one into series, we have to shift this takeoff point from here to the front here. So when we are shifting this takeoff point from here to here front, the modification what we have to do is we have to apply our fourth rule. So here we have to multiply this particular block in a series with the block here in reciprocal, that is 1 divided by G2. 1 divided by G2. So this block has to be brought in series with this particular block, or multiplication of this block with 1 divided by G2, that is this block has to be taken into care. Then what we get when we multiply these two, we are going to get the block as G3 by G2. G2. This will be the replacement which is going, and takeoff point will be there. That will show it in the next step. Let's see that one in the next step. Here shifting a takeoff point, what it has altered. So it has altered the forward block here. It has changed into G3 divided by G2. It has changed into G3 divided by G2. This is a forward block. Now here we can identify that we got one series elements. These are the series elements. So series blocks we have got G1 and G2. So when we cascade these two, we get G1 multiplied by G2, and this block is going to be in the same place, no change. But here the important thing here what we have to see is, so there is one forward signal and there is another forward signal here which is coming in parallel. By default this one is a unity forward signal. This is considered as unit forward signal. If nothing is going through this block means there is a unit inputs which is unit forward. So this unit forward block and this G3 and G2 blocks are in parallel. So when we combine these two, when we are going to combine these two parallel blocks, these two parallel blocks, so they will be getting as a parallel block element. Parallel, that will be getting as G3 by G2 plus 1. That will be equal to, so there will be a replacement of this particular block into this block. This block is going to get replaced here, and we get a replacement of a series block G1 and G2 into this system. Let's see in the next step the replacement. See here, as I have told you, G1 and G3 by G2 is going to be having a forward block 1, and it will be having G1 and G2 as a replacement for the series block, and hence this whole thing is going to be creating into one feedback loop. This is going to be creating as a one feedback loop. So the feedback loop of this one will be getting converted into one reduction block, which is having in the numerator G1 G2 whole divided by 1 it will be having a feedback of a negative, hence it will be G1 G2 whole divided by 1 plus H2. And when these are going to be in parallel, so as I have stated in the previous, it will be G3 plus G2 whole divided by G2. This is going to be, this is also a forward block and this is also by default as a one block, both are in parallel. So hence these are going to be getting parallel combination. So we get the next block as here we can see that the minor loop has been converted into the block here G1 G2 1 plus G1 G2 H2, and the parallel blocks have been written as 1 plus G3 divided by G2, and after simplification it can be replaced as a G2 plus G3 whole divided by G2, and the previous existing block is being retained there itself, only G4 1 plus G4 into. Here we can multiply between these blocks. So when we multiply these blocks, so what we get is we can cancel these elements, okay, and by default this one will be a feedback block as unity. So these whole things can be converted into a series. So the answer for this one will be G1 whole divided by, the answer for this one will be G1 G4 bracket G2 plus G3 so this will be the block which is going to be generated from this series. Okay, and we are having the feedback here. Let's see its implementation in the next step. So here we can see the forward block G1 G4 bracket G2 plus G3 whole divided by 1 plus G1 G2 H2 bracket 1 plus G4 and H1, and here we are having one as a feedback which is going to be unit feedback, which is going into the summation point at as a minus feedback. So this is a minor feedback loop. Next what we do is we are going to take this one as a G term, this whole thing as a G term, and this one as a H term. So we convert it into a canonical form. So writing the G term in the numerator as it is, and 1 plus G term into the feedback element, that is here it is 1 itself only. So it is 1. This one is going to be multiplied here. Okay. Next, after simplifying as we are done in the previous, so what we get is the step 7. The simplified answer will be as shown here, where C of S by R of S will be equal to G1 G4 bracket G2 plus G3 whole divided by 1 plus G1 G2 H2 plus G4 H1 plus G1 G2 G4 H1 H2 plus G1 G4 bracket G2 plus G3. Thank you. For any details, contact to my email ID, that is naveen.kalal@canaraengineering.in.